Okay, so these are the solutions to the worksheet from S1. So, question 1. This is telling us about a company assembling drills, and the company uses components from two different sources. Goodbye supplies 85% of the components and Amart the rest. 3% of the components from Goodbye are faulty, 6% from Amart are faulty. Represent this on a tree diagram. So the first sort of variable or choice we have is which company your parts come from. So they either come from Goodbye or they come from Amart. So your first choice is to say, or your first tree is to say that's where they're coming from. So Goodbye supplies 85%, so that's 0.85, and Amart the rest, that must be 0.15 or 15%. From Goodbye, they can either be faulty or not faulty. And the same from Amart. They're either faulty or they're not faulty. And the probability that they're faulty from Goodbye is 3%, so that's 0.03. So not faulty must be 0.97. And 6% from Amart are faulty, that's 0.06. And 0.94. So that's your tree diagram, part A, 3 marks. Part B then goes on to say, an assembled drill is selected at random, find the probability that it is not faulty. So not faulty is either this stem or this stem. That's part A. So for part B, we can either have the probability that it's from Goodbye and it's not faulty, or we can have the probability from Amart and it's not faulty. And that should give you an answer of 0.9655 for part B. Okay, question 2 is this stem and leaf diagram. So it's telling us about the number of caravans on a caravan site each night in August from this stem and leaf. So find the 3 quartiles. Well, first of all, we need to know how many there are altogether. So you can either say, well, if it's August, it's 31, or you can add all of these numbers up and get 31. So, if I want to find the quartiles, this is discrete data. We know each individual value. So, 31 divided by 4 is going to give us a total of 7.75. So, to find Q1, we must go to the 8th value. To find Q2, we're going to do 31 divided by 2. That gives me 15.5, so I'm going to go to the 16th value. And to get Q3, I'm going to do 31 times by 3/4. 3/4 of 31 is 23.25, so we want to go to the 24th value. So these tell me where I want to go in my table to get my quartiles. So the 8th value, let's just count down until we get to 8. So that's 4 plus 2, that's 6. 7th, 8th, so the 8th here is 33. So Q1 must be 33. Q2 is the 16th value. Well, if I look on this side, I can say, well, 8 plus the 2 plus the 4, that's 14 already. So up to there, that's the 14th. 15th, 16th. Here, so that's 41. So Q2 is 41. Q3 is the 24th, so if I do the same again, that's 10. 23 is there, so the 24th must be this value, which is 52. So that's part A. Your 3 quartiles are 33, 41, 52. Part B, it tells you some information about another caravan site, and then it asks you to, using the same scale, draw the box plots. So these are what the box plots should look like for this one. So this one's starting down there at 10. I'm going up to 64, it looks like, 72 down to 31, and then you can hopefully see your 2 boxes. Part C said compare and contrast the 2 box plots. So if I just show you what they gave as a mark schemes. So there were 3 marks for this, and that was for 3 acceptable comments. So something like the median of Northcliffe is greater than the median of Seaview. That's Northcliffe, that's Seaview. You'd have got a mark for that. Upper quartiles are the same. So Q3 is the same in both. Interquartile range of Northcliffe is less than Seaview. So you can see from your diagram this is smaller than that one. So that's a less than. Northcliffe has a positive skew, Seaview a negative skew. So very slightly positively skewed here and negatively skewed on this one. Or they've accepted that Northcliffe is symmetrical because this is right in the middle, and Seaview has a positive skew here with the quartiles. So they've accepted either of those. This is probably the one that we would have given to say that Northcliffe is symmetrical, Seaview is positive. And the range of Seaview is greater than the range of Northcliffe. So the range of Seaview is this, and that's the range of Northcliffe. So 3 marks, 1 for any of those. If the question has a compare and contrast and they give you a certain number of marks, that's normally how many statements they're looking for. So if it's 3 marks, try and mention 3 different things in your answer. And lastly, part D, give an interpretation to the upper quartiles of these 2 distributions. So the upper quartile is 3/4 of the way through your data, isn't it? So up to sort of 75% or under that. So what they said in the mark scheme is that on 75% of the nights on that month, both had no more than 52 caravans on site. So 1 mark would have been for knowing that it was 75% of the nights, and 1 mark for saying that it had no more than 52. That was the maximum. So the upper quartile was 52. So from there, 3/4 of the nights, or 75% of the nights, had below 72 caravans on site, or 52, sorry, caravans on site. So question 3 is a correlation regression question. Again, like most of these things, they give you lots of these sums anyway. So we want to find SXY. And from your formula sheet, you know that that's the same as sigma xy minus sigma x sigma y over n. And if you fill in your numbers to that, you get 122,783 minus 1962 times 740 divided by 12. N is 12 because you've got 12 pairs of numbers. You can count them at the top. And you should then get that that is 1,793 for your SXY. Then it tells you the equation of the regression line is this. Find the value of B. Well, that's in your formula sheet. You know that B is equal to SXY divided by SXX. You've just worked out SXY. You know SXX from your question. If you just look at the top up here, you've got your SXY is 1745. So I get that my B value is 1.027507. And they've said in the mark scheme that they'll only accept anything that rounds to 1.028. So don't round that to 1.03 basically, keep that quite large. Part C, find 3 significant figures, the mean y and the standard deviation of the weights of this sample of students. So, looking back at your table, if we're looking at the weights of the students are just the y values, so we're only looking at these y values. So, if we want to find the mean of the y, so we want to find the mean and the standard deviation of just those y values. So the mean is going to be sigma y over 12, and we're given sigma y is 740 divided by 12 is 61 2/3, or 61.6 recurring. Standard deviation, or sigma, the formula is that one. Sigma y squared over n minus sigma y over n all squared. And if you put the numbers that you've been given just above as part of the question into that formula, we get 47746 over 12 minus 740 over 12 all squared. Take the square root of the whole thing, and the answer comes out as 13.26859. And they've accepted in the answer sheet 13.3, anything that rounds to 13.3 for that answer. Okay. Okay, so question 4 was on a Venn diagram of lots of these different articles that they've tested and inspected. And it gives you all of this information, and we know that it's always easiest to start at the middle. So let's start with the middle and work backwards. So 6 had all 3 types of defects. Let's stick a 6 in the middle. 10 had both A and C. So if that's a 6, that's got to be a 4 to make the 10. 13 had type B and C. So B and C here, that's 13, so that makes that a 7. And 11 had A and B, so that makes that a 5. Then it tells us that 42 had a type C defect. We can make that 25. 37 had a type B, and 31 had a type A. And then all together, if you just check a bit further up in your question, it tells you that there are 1,000 articles. So all together in this Venn diagram, there needs to be 1,000 articles. So that makes the outside 918. So part B, find the probability that a randomly selected article from this sample had, first of all, no defects. So no defects is, we can look at our diagram, it's 918 out of 1,000, or 0.918. Part C, no more than one of these defects. So no more than one, we can either have this 918, none, or we can have 25, or the 19, or the 16. So no more than one is these 3, or none. And that's again all out of 1,000. So that answer is going to be 0.978. And then the last one says, an article selected at random from this sample had only one defect. Find the probability that it was a type B defect. So we're basically saying, find the probability that it was type B, given that it only had one defect. So we're remembering that that is a probability of B intersect with only one defect, divided by the probability of only one defect. So if we look at our Venn diagram to find out what that probability is going to be, the probability where B intersects with only one defect, well, only one defect are these 3 areas. So the B bit of that is 19, out of the probability that you only have one defect altogether is the 16 plus the 25 plus the 19, which is out of 60. So the probability it only has one defect is 19 out of 60. Part E says 2 different articles are selected at random. Find the probability that both had type B defects. So we're saying the probability of a type B from one, and then the probability of another type B. So the probability that any article you pick has a type B defect is going to be 37 of them out of 1,000. If you've already taken one of those out, the next probability is going to be 36 out of 999. And that calculation comes out as 37 over 27750. Or if you want it as a decimal, it's 0.00133 as your final answer.